All right, here's the second example I'm going to post on my blog. I'm also going to post another vector example, but this one has to do with the parameterization of a line segment that connects those 2 points. So visually, what we got going here is, I'm just going to quickly sketch an x and a y axis. All right, and then let's see, we're going -4, -5, so 1, 2, 3, 4, 5. 1, 2, 3, 4, so -5, -4. Here's my first point, I'll call it A. And then my second point is at 1 up 2. 1 up 2, I'll call that B. So I'm trying to find a parametric equation that models that would graph, let's see here, graph that line segment, and only that line segment. Nothing beyond it, nothing before it, only that line segment. So what I'm going to do is I'm going to pretend that there's a little bug that's starting at point A. And that's when time is equal to 0, and it's walking in this direction, towards point B. After 1 second, it reaches point B. So it takes 1 second to travel that distance. And if I think of it that way, I can make a table to model the bug's path. So when time is at 0, the coordinates of the bug are -4, -5. When time is 1, at 1 second, the coordinates are 1 and 2. All right, so the table is pretty simple to fill out. Here's the key. A parametric equation has 3 parts to it. It has a x equation, a y equation, and an interval for t. On the interval, the time is just going to go from 0 to 1 second. And then we just got to find equations for x and y. Those equations are going to be in terms of t, and because our graph is a line, they're also going to be in the form of mx plus b, or in this case, mt plus b, because they're in terms of time. So, for the x equation, I'm going to look at the x column and time. X depends on t in that x equation. So the starting value for x is going to be the b of the equation. X is -4 when time is 0. It starts at -4. And my slope says that whenever t goes up 1, my x goes up 5. That's my slope. That's the definition of slope, is how much does the dependent variable increase or decrease when the independent variable goes up by 1. So t goes up by 1, x goes up by 5. That's my slope. For y, I'm going to use the y column, and it depends on t. So y starts at -5. And when t goes up 1, for each time t goes up 1, y looks like it goes up 7. And like I always do on these problems, I always put x instead of t. I always do that. Alright, and there it is. There's a parametric equation. And it only graphs that line segment. What's cool about a parametric equation is that I can change the length of the line segment that I'm graphing only by changing the interval. Maybe I'll talk about that in another video. For now, I'm just going to stop there with that one.